In this web page, if you click here, sequential feature selector, you can see the parameter you should set and example code. So when you look at the example code, please remove this part when you apply the code, because this is an example dataset, which we don't need it since we already have a dataset. So you call the function, and you should also have one model. So this model is used to select the features. So in the previous video, I mentioned that actually feature selections are done by training a lot of models. So you need to specify which model are you going to use in feature selection. So based on this, I have this code. So I'm using linear regression in feature selection. So I declare the model, this linear regression, and use sequential feature selector. I guess you can select backward or forward. Here you can see direction. Direction is forward, but you can change to backward. I guess you can change it to backward. So for this parameter, you have two options, forward and backward. So you can choose one of them. And basically it's forward, default is forward. So I didn't specify direction parameter. Here I tested with number of features to select is 6. So it's quite simple. I define the model, use the model, and give the number to select, and then provide the data set. So here I gave descriptor, normalized descriptor, and the endpoint. So this is X values, and this is Y endpoint. That's it. Then it will do the task. Actually, it takes some time. And if I want to check which descriptors are selected, I need to use this one. If you only type this one and run, you will see true and false values. So it gives, let's say if I have a descriptors, since I select 6, okay, 1 2 3 4 5 6, this is a selected one, but my descriptor is actually much longer. For example, it's 600. Is it 600? No, it's 1000. Anyway, it's 1000. Okay, so it gives this one. So this get support returns true, false, 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 true, something like that. So this one is selected. This is not. This is not. This is not. Not. Okay, this one is selected. Not. This is the SFS jump dot get support. This is the return value of this SFS dot get support, get underbar support, true and false values. So I put this in this column so that only the selected descriptors may be displayed. Well, it takes too long time. Okay, let's get back to it when I get the result. Anyway, so I specify the descriptors I selected by this for selection. So from now on, what I need to do is split the data set I need to split the data set because um, I trained the model with training set, but I'm not sure if the model I trained is working well for the unseen data set. So this model already saw this data, but this is unseen data set, although these two should have similar distribution. So if training works quite well on this data set, then it should be able to predict well on the test set, although it is unseen before. That's why I need to split the data set so that I can test the model if the model is truly showing the good performance as it works well for the training set. So this is the purpose of the training and test set. So I divided, there's a function in scikit-learn for train test split, which split the dataset into two part. So here I input two data frame. So you see, it split the dataset. If I provide only df, then I will have these two. But since I input two data frame, I have four values. So it's splition. It's a split of this. This data frame is split into two, and this one is split into two. So this is you can put more data for a split, and you should also increase the variables to take the return value from the function. Okay. So I select the endpoint alone from here, and then also I select descriptors from xtrain. So this is my preparation for the selection. And then I'm gonna select the features. So I'm using here for loop. So for loop is to do some tasks repeatedly by changing one or two options in entire code. So here I is a variable used in the for loop, and it's used here to specify the number of features selected. So range 2 to 10 means from 2, 3, 4, 5, 6, 7, 8, 9. If it started from the beginning, this should be the 10th element. But I specify that you should start from 2. That's why it's starting from here and then up to here. 10th element. Okay. So I'm gonna use linear regression, and I use linear regression and then specify the number of features. And then I put descriptor and the endpoint for prediction. So if you see the result, first it's selected two features, and then it run the code from here to here. So why this is printed? Because of this. I ask it to print features and also this. So this first line is coming from here, second line is coming from here. These two lines are printed in every loop, every iteration. So if you see what you get on the second line, I inputted test set and check if the model how a model performs with the selected features. So you see, first I use this one to fit, which means selecting the descriptors, and then I find the selected features and select the descriptors from training set and test set, and then test the model. So I fit the model again and test how it performs on test set. So it was 0. 0.5, 0.55, 0.51. So it's increasing, decreasing, increasing, increasing. You see, um, it's working well. It should work well for the training set, but not always for test set. So it's important to test it on the test set. So this is how folder works, and so this is the result I can get. But I mentioned that I want to generate learning curve, which means there should be number of descriptors, and this should be a score. To make this plot, I need to save data for training data and test data. So I need to save these score values at each number of descriptor. So I rewrite the code. The above one above cell didn't run because this cell is still running. Says there's a slight modification. I commented print and I added this append. So I defined two lists. So first list saves score from training set, and the second list saves score from test set. So here I calculate the score and added it to the list. So if you use the list, you can define empty list first, and then you use append to add values each value to the list. So in this case, it runs, for example, I should be first 2, and develop the model with the two descriptors. So two descriptors were selected, and the models were developed with its selected two descriptors. And then I test it for training and test both, and then save the value to the list. So if I have full elements in the list, then I can make this plot using these two lists. Okay, so run the code and you will see the plot in the next